And welcome to our Fields and Features segment. We'll be talking about all kinds of magnetohydrodynamics, ground magnetic perturbations, sunspots, coronal holes, solar flares, and more. So won't you join us? Here's the last 4 hours of Earth's magnetic moment from space, showing magnetohydrodynamic pressure. There's a bunch of plasma surrounding the Earth. Here's where it's likely located. Here's the magnetohydrodynamic pressure likely around planet Earth as modeled by the Space Weather Modeling Framework over the past 4 hours. We're going to let that play through all the way to get a continuous 4 hours of data there. So just bear with me a minute here. We've got some spectacular close-up imagery of the closest star, El Sol, aka Helios, aka the local yellow dwarf, aka the Sun. So here are our ground magnetic perturbations. Interesting magnetic pulse coming out of the Central Pacific Ocean, right around here. Right around here, over this area. Like the last video, that's the last 4 hours of Earth's magnetic moment from the ground, modeled in nanotesla magnetic flux density, as opposed to magnetohydrodynamic pressure. Nanotesla is the units that we're showing. Next, the GOES magnetometer over the past 3 days. We do have another coronal hole wind stream showing up soon, and it's been delayed a little bit. Make sure you watch our previous space weather video. You can find that one at youtube.com/smashamash exclusively. Next, the heliospheric current sheet and its polarity. And we are expecting a North Pole current sheet to be making its way around here pretty soon. So let's keep an eye on that. And when I say eye on, oh well, pardon the pun, Earth is currently in a South Pole current sheet shown here in red. Yeah, the plasma is oriented to one pole or the other. The Earth is in a South Pole oriented sheet of solar plasma. Yeah, the sun, it's blasting out a solar wind. As forecasted by Eugene Parker a long, long time ago. Anyway, here's the ecliptic plane field plot, the line of sight view. A lot of magnetic activity there on the Earth-facing side of the solar disk. It looks nothing like a grand solar minimum because it's clearly not a grand solar minimum. Look at the trans-equatorial coronal holes here, as the south solar polar field slowly makes its way to the northern region and vice versa. That's what a solar cycle is, folks. It is the reversal of these solar polar fields and the basis for the sunspot cycles. We've got ideas as to how it occurs. Here's a great visualization here in 193 angstroms. That's ultraviolet light, by the way, if you're wondering. 193 angstroms is one of the many ionized species of iron. And this event you saw up here, that was a flare, and it was more like a filamentary reorganization, it looks like, not a coronal mass ejection. Most of that plasma must have splashed back down onto the sun. And let's move into sunspots. So the sunspot number is going to go up once again today because we've got sunspot 2959. We'll be getting its name today. In fact, I think it should have gotten its name yesterday, but in any case, we've got 2954 and 2955 and 2956. They're all alpha class sunspots. I'm not sure if 2956 is even a thing. Make sure you tune into our bonus segment, our bonus features segment, that is. Sunspot 2958 has produced some flaring. It's not particularly huge umbrae. 2957 and 2959 are quite spectacularly large sunspots, as you can see over here on the intensity gram. Flare probability continues to rise. Most likely area, in my opinion, is sunspot 2959. 2957, also capable of producing large flares, in my opinion. So here's 1700 angstroms, one of the other UV spectrum wavelengths that we regularly look at. It's good at showing the dark spots where we see solar umbrae, the basis for what a sunspot is. And if you're thinking these look more slow, it's because we've slowed them down to 15 frames per second. We usually show 30, but we're just not in a hurry at the moment. Once again, thanks to the SMASH team. And we've squeezed in 2957 and 2959 2959 is quite a large sunspot. It's quite magnetically complex. It's beta gamma class. That's this one down here. 2957 is also beta gamma class, I think. And make sure you tune into our bonus features segment to verify that. We did see a number of C-class flares here, 4 of them. Since yesterday, the largest one happened at about 2150 Universal Time yesterday on March 3rd. It was a C3.3 class solar flare. A great wavelength to view solar flares is indeed 94 angstroms. So here's a great view of that. And we saw sort of a simul flare moment here. I think the C3.3 came out of this area. We also saw a flare around this active region over here, which is currently not a sunspot. At least when we did show prep, it was not a sunspot. Just a plage, an active region. And another great wavelength to view solar flares is 131 angstroms. Here's a close-up of the northern hemisphere. So none of those C-class flares caused any relativistic particles to make it to Earth, as we see a flatlined proton flux, just a background level there of protons. Let's move on to the real-time solar wind. To see a little uptick here in the solar wind speed. Solar wind speed now around 480 kilometers per second. Solar wind density about 8.3 protons per cubic centimeter. KP index is at 2. That's a measurement of global geomagnetism, each bar representing 3 hours there. KP2 is the current situation. Next, looking at our solar system forecast. Here's where heavenly bodies are now. There's where things will be in a week. We'll have a gibbous waxing moon by then as we approach our next full moon. And we've also brought up a star chart here. Here's what's going on above our head in Lehigh Valley, Pennsylvania. It's in-the-sky.org. You may see Mars and Venus side by side there on either side of the ecliptic. And Mercury and Saturn also rising ahead of the sun. Just put in your location and use the all-sky chart is what we're using. Mine's facing to the south. That's where the ecliptic's located. That's the direction I'm currently facing and the direction my sofa faces. And last but not least, we'll look at the coronal mass ejection watch, the view from stereo A at Lagrange 5, and the LASCO SOHO C3 at Lagrange 1. We don't see any coronal mass ejections, an indication that that solar plasma has splashed back down. Associated with those flares, we don't see anything coming out of the sun. And for you new viewers out there, the LASCO C3 puts the Earth behind you. Stereo A puts the Earth off to your right from its perspective. Again, LASCO C3 located here at Lagrange 1. Stereo A located at Lagrange 5. The coast is clear when it comes to coronal mass ejections. Thanks for tuning in, folks. Thanks to the SMASH team. And may that solar wind be at your back.